And finally, we come to another very common variant of the chi-square test, but one that can be very dangerous when it comes to its use. It is very common because of its name and because of the reason why it was developed, but it can be dangerous because sometimes people misunderstand what its name is and end up using it in inappropriate situations. Okay, what is this thing? This is called the Fisher's exact test. Okay, and this is a test that compares proportions of a dichotomous variable in two groups. Okay, before we parse what that means, let me tell you that the fellow in the picture is Sir Ronald A. Fisher, and he is the fellow who actually pretty much invented or developed all the basis for hypothesis testing, and he also developed this particular test. So he's a very, very important statistician, mathematician, scientist, and you may want to know a little bit more about him. There is a link in the book to a site that tells you more about Sir Ronald Fisher, but he's a very, very important contributor, a very, very important scientist of the 20th century. So let's go back to the test and let's try to understand what it does. So this Fisher's exact test compares the proportions of a dichotomous variable, that means it only has two values, in two groups. So we're still talking about proportions, so we're still talking about sort of a chi-squared situation, but it's a very simple one. We only have two groups, G1, G2, and we're dealing with a variable that only has two values, yes or no. Okay, very simple situation, so it looks very nice. And why is this test so common and so commonly used? Well, because it does not require the sample sizes, the expected frequencies to be large. I mean, it can work with small sample size. It can work with small expected frequencies. Okay, so that's good. That's great. Not only that, but when it can work, when we can use it, it actually gives us, as the name says, an exact p-value. That's why it's called Fisher's exact test. So there are two advantages of this test over the chi-square test. One is that it does not require large sample sizes, so you can use it even with small samples. And two, it computes the p-value in an exact manner rather than approximation. So where is the rub? It looks like it's a really good test. So where is the rub? Well, the rub is in one of the requirements. Remember, one of the big requirements about the chi-square test is some totals have to be fixed. Well, Fisher's exact test only works if all four totals are fixed in advance. So that means that not only we need to figure out how many people to sample in each of the two groups, but we need to fix in advance how many yeses and how many nos we're going to get in total. You can imagine that this is a very tall order, and in many clinical situations you cannot predict in advance how many people are going to be cured, how many people are not. So in fact, in most situations, Fisher's exact test really should not be used. Does that make it a very bad test? No, not really. The one thing to remember is that if this requirement of predetermined totals is not met, then the reliability of the test is questionable. In fact, I would say that this question is not very robust. Okay. However, it does not make it a bad test. It makes it a test that still can be used, still can be relied upon as a good tool. Okay? But one has to be careful in how one interprets the conclusions, how one interprets the results. Some people say that it is okay to use the Fisher's exact test as long as we say, well, this is the p-value assuming that the yes-no totals were the ones we saw. Okay? But what does that mean really? Okay, so it's a little bit of a head scratcher situation. Okay, so once again, use the Fisher's exact test. Don't throw it away. Don't think of it as a bad test. Okay, but don't think of it as an exact test either, and don't think of it as a uniformly better test than the chi-squared. It is not, unless all the requirements are satisfied. So use with care, but do use it and do respect it, and do consider the conclusions it gives with a good as a good indicator of what the situation is in the populations.